Alright everybody, this video is going to be a little bit shorter than the normal ones. Just going through one problem, just sort of going through the basics of how to do a proof. A few rules of thumb. Proofs are all about justifying, which means that whenever you make a decision, or whenever you make a claim, you're going to have to explain why you did what you did in order for it to be accepted. So just keep that in mind as you're going through things, otherwise this is going to be a really tough process. Secondly, with these triangles, remember that what you're going to be doing is you're going to be showing, like for side, 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 which is the only one you've learned about at this point probably, you're going to need to show that all the sides are the same. All the sides are congruent. So that's what you're going to be aiming for. But you're going to be learning about some other theorems soon that will require you to find angles as well, or instead of some of the sides. So what you're going to need to just keep in mind is that you're looking to find parts of triangles that will help you prove that triangles are congruent. So what we're going to do is we're going to go through an example that uses side, 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 and we'll talk about how to show that all three sides are the same between the two triangles. So here we have it. Write a proof. And we're given some information, and you'll always be given some information that you may need to use in the problem. So, in this one, we're given that KL is congruent to NL, and you can see they've already marked that for us in the picture. And we're also given that KM is congruent to NM, right there. Also, they drew that into the picture for us. And we need to prove that the triangle KLM is congruent to the triangle NLM. So, what we're going to do is we're going to have a three-step process. Why 3 steps? Because in order to use side, 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 we need to show that 3 sides are congruent. So, first step. Well, actually the first 2 steps on this one are going to be pretty easy. First step we can do is we can say that KL is congruent to NL. Why? Don't really have a theorem to use for it or anything for this one. We can just say that KL is congruent to NL because it was given to us. So, KL and NL are congruent because this info was given to us. Two, you can probably guess what the second step is going to be. It's basically going to be the same thing as the first step. KM is congruent to NM. Why? Because this information was given to us. Same reason. Now the last side is going to be a little bit different. Because here's our last side, we have LM, and I'm claiming that LM is the same length in both triangles. And it makes sense that it's the same length, doesn't it? Because it's just the distance from L to M, and it's the same line segment between both triangles. Now the way you're going to write this one is you're going to write LM is congruent to, technically, LM is congruent to, well, LM again. And whenever you have one like this, where you have a line that's just shared, what you're going to say is because of something called reflexive property. So whenever you have a line shared between 2 sides, and that's your justification for them being congruent, it's reflexive property. Reflexive because you have the exact same thing on this side of your congruency as you do on this side. Before this video ends, just a few other things to keep in mind. Some things that can tell you other things, like let's say that we had this picture. Let's say that we had A, B, C, and then here we had D. And let's connect those two. And let's say that part of the given information was that D is the midpoint of AC. Well, one thing to keep in mind is that sometimes you're going to need to use, you won't just directly be able to use the given information. You're going to have to take it and turn it into some other piece of information that's useful. For example, if we're told in this one that D is the midpoint of AC, what that will then tell us, which we might actually be able to use later on, is that AD is congruent to DC. How do I know that? Well, if D is the midpoint of AC, that means that it's splitting AC into two congruent halves, two halves that are equal. And you can probably tell that knowing that AD and DC are the same length may be easily useful in proving that two triangles are congruent. So you're going to have to kind of keep an open mind and be on the lookout for using some of these theorems. You might see parallel lines and transversal angle theorems popping back up that you need to use. You might see this idea of the midpoint or a bisector. You might see, there are a few different ways that we can show that things are congruent and can require you to know some other information to do so. So, just a few things to keep in mind as you work on proofs. You'll be seeing a few examples in upcoming homework assignments. Ask questions if you don't get it. And that's about it for this video. So, I will talk to you later.